Okay, it's recording. So the first one we did was something like this. We said you have 6x squared minus x minus 1 over x times x squared minus 1. Okay, that's what we have. And when we want to decompose it into its partial fractions, we can factorize the denominator, because here the denominator is possible to be factorized further. So I would have 6x squared minus x minus 1 over x, and then I have x minus 1, I have x plus 1, like that. Now if you look at my factors in the denominator, none of them is repeated, so that is the key. So when none of your factors are repeated, what you will do is you rewrite this. Say when I decompose it, I will have a over the first factor, b over the second factor, and then c over the third factor. Okay, and then when you have a fraction like this, a over x plus b over x minus 1 plus c over x plus 1, when you combine them, you look for the lowest common multiple, and then that is your denominator, and then you'll multiply the numerator. Yeah.
What do you mean by the factors are not repeating or are not repeated?
It means it's not, I can see only one. This x over here is a factor. There's only one of it. This x minus 1, there's only one of it. So it's not repeating. I don't see it twice. It's not squared or anything like that. That's what I mean. Okay. All right. Then I will combine them. So I will have here, I'm only going to look at my numerator because of the space that I have over here. So my numerator will be a x minus 1 plus x plus 1. Okay, and then b x plus 1, and then c x, and then x minus 1. So I multiply each of the numerators by the denominators of the other two fractions, and this must be equal to the numerator I have in the original equation, which is this one over here. So this must be equal to 6x squared minus x minus 1. Then we said there's a technique we can use where you want some terms to cancel. So you can start with when x is equal to 0. So when x is equal to 0, if I substitute x is equal to 0, you will see that this factor or this term over here will disappear because there's an x there. It's 0. It'll multiply everything. I'll get 0. The same thing over there. When I substitute x is equal to 0, that will cancel. So the only term that I will have left is this one here. So I write that. So I have a, then I have 0 minus 1, which is just minus 1, and then I have 0 plus 1, which is just 1. So that's the only thing I'll have left on the left-hand side. Then on the right-hand side, when I substitute 0 there, I get 0. 0 over there, I get 0. The only thing left is minus 1. So when I multiply this out, I get minus a is equal to minus 1, which means that a is equal to 1. Okay. Then I do the same thing with b, or with the next one. So here I see when I substitute minus 1, x is equal to minus 1, some of the terms will cancel. So I have x is equal to minus 1. Now when x is equal to minus 1, I go back, you will see that this term here will be 0. So when it multiplies out, the whole thing is 0. This one here will also be equal to 0 because x plus 1, that will be 0. The only term on the left-hand side left is the one with c. So I write that down. So the term with c, I have c, and then x, this is minus 1, and then I have minus 1, minus 1, and then on the right hand side I do the same thing. When I substitute, I have 6 times minus 1 squared minus negative 1 minus 1. So I substitute it there. So this is equal to 6 times minus 1 squared minus negative 1 minus 1. Okay, simplifying the left hand side, I have negative 1 times negative 2, which is just 2. So I have 2c. And then on the right hand side, you'll see that these two will cancel because this is positive 1 and that is negative 1. They give me 0, and then negative 1 squared, that is just equal to 1. So it's 6 times 1, then I get 6. So this means that C is equal to 3. And then the last substitution, if I make x is equal to 1, you will see that the first term disappears because I have x minus 1, and the last term with c disappears to get 0. Then I have only an equation with b in it. So you can say that x equal to 1. Now when x is equal to 1, I have b times 1, and then 1 plus 1, and then on the right hand side over here I have 6 times 1 squared minus 1 minus 1, so that should give me 4. So I have 6 times 1 squared minus 1 minus 1, then this is just 2b, this is equal to 4, and this means that b is equal to 2. So I've worked out all the values for A, B, and C. So I go back and substitute them here. So A, we say it is 1, so I will put 1 there. Let me just write that. So we say this is equal to 1. B, we say it is equal to 2. And C, we say it is equal to 3. So I need to write that down as my final answer. So when it's decomposed into the partial fractions, so it's decomposed into the partial fractions, we have A, which is 1 over x, B, say it was 2 over x minus 1, and then C, x plus 1. So this is what we did in the last class. There's more questions in your notes. You just need to practice because there isn't really anything difficult we are doing. It's all basic addition, solving simultaneous equations, and that. Then today we look at what happens when we have linear factors, but then some of them are repeated. This is the question you are asking. An example of this is this one here. 3x minus x squared plus 1. And then I have to decompose this into its partial fractions. So I have x minus 1 squared and then x plus 2. So you can see this is factorized, but you could look at the denominator in this way. The denominator, I wanted to use a different color. Now the denominator, you can look at it as x minus 1 times x minus 1 and then x plus 2. This is what the denominator is. And you can see this factor here, x minus 1, is repeated because it is appearing twice. Now, usually for the first one that we did, we said that I would write a over x minus 1 plus b over x minus 1 plus c over x plus 2. This is how I would normally solve it. But you will notice that if I were to combine these fractions, I would get a denominator of x minus 1, x plus 2. It wouldn't be squared because these two have the same denominator. So we have to do this one differently. Okay, so it doesn't work in the same way that you just write it with its factors, and whether they're repeated or not, you just put A over the first one and B over the second one. No, so this way it will not work. So what we do when we have repeated terms is we need to build up to that power that we have over here. So if this is 5, you will do this till you get to whatever that power is. You start with 1, 2, 3, and so on. Now the way we do it is, because what I'm squaring is linear, my numerator will still be a constant. That means the degree is 1. Now the way that I do this, I will say A over x minus 1, and then B over x minus 1 squared, and then C over the second factor. Now if I was to combine the denominators, lowest common multiple of the denominators will now be equal to x minus 1 squared, x plus 2, because this term here and that one, the denominators are not the same, so I cannot just add them. I would have to change it. Okay, so if I had power 3, I would then have C over x minus 1 power 3, and then add D over x plus 2. Okay, so whatever the exponent is over there, you'll start with power 1, power 2, power 3 until you get to that one. So if it's 10, 1, 2, 3, you'll have all those terms up until 10. And then you may notice some of them might be equal to 0 in your final answer. Okay, so this is by the way. All right, then we do it in the same way that we always do. We look at our numerator. So I need to change this denominator to the LCM, which is this one that I have over here. So the only thing missing is x minus 1, so that it becomes squared, and then x plus 2. Okay, then it looks exactly like the one I have over here. Then B is missing just x plus 2, and C is missing x minus 1 squared. Okay, so that is my numerator, and it must be, okay, this is C, and this must be equal to the numerator I have in the original equation, which is 3x minus x squared plus 1. Okay, so this is all in one line, just that I don't have space. Okay, then you do the same thing we do, can let x equal to something. So we can say let x equal to 1. So when x is equal to 1, you can see that this term over here will disappear because I have 1 minus 1, which is 0. This term over here, the C, will also disappear because I have 1 minus 1, which is 0. 0 squared is still 0. So the only term left will be the one with B. So I have B, and then I have 1 plus 1, 1 plus 2. And then on the other side, I put 1 there, and that one remains the 1. So I have 3 times 1 minus 1 squared plus 1. So here I have 3b. This is equal to 3, and that means b is equal to 1. So that is my first solution. Then I go back and see, can I substitute anything to get rid of one of the other terms? So if I substitute x is equal to minus 2, you'll notice that this term with a will disappear, this term will b with b will disappear, and I will be left with c alone. So I have here, when I let x equal to minus 2. So I will have C minus 2 minus 1 squared. This is equal to, I substitute on the right hand side, so it's 3 times minus 2 minus negative 2 squared and then plus 2. So this is equal to 3 times minus 2 minus negative 2 squared plus 1. Right. Then on the left hand side, minus 2 minus 1, this is equal to negative 3. Negative 3 squared, that is equal to 9. So I have 9C. And then on the right hand side, I have 3 times minus 2, that's minus 6, minus 6 minus 4 plus 1. That should be equal to negative 9. Okay. Then you divide by 9 on both sides, you get C is equal to minus 1. Okay, so now I have C. Then we go back again. Now you'll notice that there's nothing else you can cancel. We still have to solve for, let me see, we solved for B and we've solved for C. So there is no term that we can substitute to make B and C disappear so that we're left with A alone. Because if we substitute negative 2 here, the A will disappear. If I substitute negative 1 there, the A will also disappear. Okay, so what we can do is you're now free to substitute any number you want to, because you know the value of B and C, then you'll have an equation only in terms of A. Now pick your values in a good way so that you don't have to do a lot of work. So you can pick minus 1,000 over 3 if you want to, that's fine. But the calculations you will have to do is a lot. So I will say let x equal to 0. So we let x equal to 0. Okay, now if x is equal to 0, you see over here, I will have A times minus 1 times 2, B times 2, C times minus 1 squared, which is just times 1. And then on the right hand side, I'll only have 1 left. So I don't have to do a lot of calculations or any difficult calculations. So I will have A times minus 1 and then times 2, B times 2, then C times minus 1 squared, and then on the right hand side I will have 0 because it's 3 times 0, which is just 0, and then minus 0 squared, which is just 0, and then plus 1. Then I simplify, I have minus 2A plus 2B plus C. This is equal to 1. I already know the values of A and B, so I have not A and B, of B and C. So I know that C is minus 1. This is minus 1. And B, we got 1. So I can substitute those ones as well and then solve. So I have minus 2 and A, I still don't know what it is. This is plus 2 minus 1, and this is equal to 1. So I solve this. The 1 goes to the other side, I have 2, and then the 2 goes to the other side, I have 0. So I have minus 2A is equal to 0. That means A is equal to 0. Okay, then I go back and substitute them over here. Where is that? Over here into my decomposition. So A, we said A is 0. B, we got 1. And then C is equal to minus 1. So you can see I was building up to x to the power of 2 but the linear one that didn't have a square disappears. So sometimes when you have 3 or 4 terms that are repeating, you will see that the lower ones disappear and you're left with just a few terms. So we write the final answer. So my decomposition, I have A was 0, so I'm just going to write it and then write it nicely. And A was over x minus 1. My B was 1 over x minus 1 squared. And then my C was negative 1, so I don't need to write this as positive. I just write it like that. 1 over x plus 2. And then finally, I can just say this is 1 over x minus 1 squared minus 1 over x plus 2. Okay, so this here is my final answer. And that's what we do when we have repeated factors. Okay, so the others, we would do them in pretty much the same way. So I think we have, let's just do one more with this one. And then we move on to the next type. So here I have x squared plus x plus 2 over 3x squared minus 2x minus 1, and then I have x minus 1. Okay, so first thing we always need to check is the degree of the numerator less than the degree of the numerator? If it is less than, you may proceed in the way that we have done. If it is not less than, you must first perform long division. And then when you have a degree in the numerator that is less than in the denominator, then you can use any of the techniques that we have done. Okay, so to do that, here I can see that the degree of the numerator is less than, because when I multiply this out, this x squared and this x over there, when they multiply, I'll have x to the power of 3. So my denominator has a degree higher than the denominator, so it's fine to proceed. But I look at my denominator, the first factor, I can factorize this, so it's quadratic, so you can factorize it. So go ahead and factorize that. So here I have x squared plus x plus 2, and then when you factorize this, you should have x minus 1, and then 3x plus 1. Okay, so I hope I factorized it correctly. So you can confirm that is correct. You know how to factorize it, so that's why I didn't show any of the working. Then when I look at this denominator factorized, I have one factor here that is repeating. So what I do with factors that are repeating is I build up to it. So my first term will be a over x minus 1. The second term will be a over x minus 1 squared, and I stop because there's only 2 of them. And then the third one, c over 3x plus 1. Okay, then now that I have it like that, what I do is I multiply the way I normally do. So I will have a times x minus 1 times 3x plus 1, and then b will only multiply with 3x plus 1. Okay, I can't seem to close that bracket, but you should close it. And then c is missing x minus 1 squared. And this should be equal to what I have in the numerator over there, the x squared plus x plus 2. So this is equal to x squared plus x plus 2. Then I will do the same thing where I cancel out terms to solve for one of the letters A, B, or C. So I see if I substitute x is equal to 1, the first term with a will disappear, and the last term with c will disappear. Then I'll be left with the term with c. So we let x equal to 1. So when x is equal to 1, we said a disappears, c disappears. So I have the term with b, and then I have 3 times 1 plus 1. And then on the right hand side, I must do the same thing. Substitute 1, 1, and the 2 remains as it is. So this is 1 squared, which is just 1 plus 1 plus 2. Then on the left hand side, I have 3 times 1 plus 1, that is 4. So I have 4b. This is equal to 4, and this means that b is equal to 1. Okay, so that is my first one. And then I go back and see, can I substitute anything to make the other two letters disappear? If I substitute x is equal to negative 1/3, you'll see that this term here disappears. The one with a disappears, the one with b also disappears, and I will be left with the one with c, and I can solve that one. So I do that. So we let x equal to negative 1/3. Okay, and then when x is equal to 1/3, what I have is b minus 1/3 minus 1 squared. Let's just see. Okay, no, it's c. Okay, so I have c, and then I have negative 1/3 minus 1 squared. And then on the right hand side, I have negative 1/3 squared plus negative 1/3, then plus 2. Let me just write this better. So it's negative 1/3 and then plus 2. Then you take your calculator, negative 1/3 minus 1, that is negative 4/3, and 4/3 squared is 16/4. So I have 16 over 9. 16/9 times c. And then on the right hand side, you do the same thing with your calculator. Negative 1/3 squared, that is 1/9, minus 1/3 plus 2. Here I got 16/9. Okay, then when you work that out, divide by 16/9 on both sides, you get c is equal to 1. So that is your second solution. Then you go back again and see, I've solved for b and c. So I'm trying to find something that if I substitute a will disappear. But when I look at a, if I substitute here, so I want a to be left. So if I substitute minus 1 to get rid of that one, you will notice when I substitute 1, you will notice that a disappears with c. And if I substitute minus 1/3 to get rid of that one, a also disappears. So I use what I did previously. I can say let x equal to 0 because it's easy to work with 0. So we let x equal to 0. Now when x is equal to 0, what I will have is, let me write it. So here, if that is 0, then I have minus 1 there. Then this one here is 1. And b, this bracket here is 1. And this bracket over here will eventually be equal to 1 because it's 0 minus 1 which is minus 1, and then minus 1 squared is equal to 1. And this will just be 0. This term here will be equal to 0, and then I'll be left with 2. So let me just write that down. So we'll have A minus 1, 1, B times 1, and then I have C times 1. Okay, let's scroll back. So write it here. So we have A, this is minus 1 times 1 plus B times 1, and then C times 1, which is just C, and then on the right hand side we said we will only be left with 2 because we have x squared is 0, x is 0. When I add that to 2, I'm only left with 2. So here I have minus A plus B plus C. This is equal to 2, but we already know the values of B and C. Yeah, B is 1 and C is 1. So B, we say this is 1, and this is also equal to 1, so I can substitute them there. So you can see it's very important that your previous calculations are correct because they affect the answers that you get afterwards. Then when I do that, I have minus A plus 2 is equal to 2. This means minus A is equal to 0. And that means A is equal to 0. Okay, so I go back here. I will substitute and rewrite it nicely. So my A, I say it is 0. My B, I got 1. C, I got 1. So when I decompose it into the partial fractions, what I have okay, so decomposed, I will have 1 over 3x plus 1 plus 1 over x minus 1. Minus 1. Just pull up. Okay. Minus 1 squared. Okay, so there is decomposed. That is your final answer. And then you can always check, combine the two fractions, check if what you get is indeed the one that you started with. Okay, you can look at one more with repeated. Let's say I have 9x squared plus 6x plus 2 over 3x plus 1 cubed. Okay, so here I have only one factor and it is repeated 3 times. So when I decompose it into the partial fractions, this is what I will do. This is A over 3x plus 1. That's the first one. B over 3x plus 1 squared. And then the third one, this is C over 3x plus 1 cubed. So notice I am building up to this 3 over there. Okay, so if it's 5, like I was saying, I must have 3x plus 1, 3x plus 1 squared, 3x plus 1 cubed, 3x plus 1 to the power 4, 3x plus 1 to the power 5, just like that. So I do not skip any of them. Then what I do end, very important, my numerators, these are linear, because I don't look at it and say this is quadratic. Sorry, I meant it's a constant term. There's no x in the numerator. So I don't look at this one and say it's quadratic. I still look at it as 3x plus 1, but just with the square. Then what I do, again, This is just a multiplied by 3x plus 1. It's missing the square. And then b is missing only one of them. And then c is not missing any of them because the lowest common multiple is already the denominator of c. So I would normally multiply it by 1, but multiplying anything by 1 doesn't change. And then my denominator should still remain, the right-hand side of the new right-hand side should still be equal to 9x squared plus 6x plus 2. So that's what I have. Then I follow the same procedure. If there's anything I can substitute to make one of the others, A, B, or C, disappear, I do that. So I see that negative 1/3 will work. So I say let x equal to negative 1/3. Then we see that this term over here, the first one with A will disappear. The second one with B will disappear. Then I'll be left with C by itself. So I have C is equal to 9 times negative 1/3 squared plus 6 times negative 1/3 plus 2. So C, here you work it out on your calculator. 9 times 1/3 squared plus 6 minus 1/3 plus 2. You should get C is equal to 1. Okay, so I've solved for C. Then I go back and see, is there anything else I can substitute to get rid of maybe the A term and the C term? But with the C, because C is just C, it's not the value of X. There's no value of X you can substitute to get rid of C. So it's only A and B that you can get rid of. But you can see that the 3x plus 1 is the same as the 3x plus 1 over there, except one of them is being squared. So if you make one of them 0, the square will obviously also be equal to 0. So what you can instead do is substitute something like 0. So substitute, let x equal to 0. Now if x is equal to 0, when I substitute it over there, I will have 3 times 0 plus 1, which is just 1. And over there, I will also have 1. So I'll have A plus B is equal to 2. So when I substitute that, when x is equal to 0, so I'll have A times 1 squared. And then B plus 1. And then the C, I shouldn't forget about it. C is equal to, on the right-hand side, I have 2. But we already know the value of C, so I can substitute that. So I have A plus B plus 1 is equal to 2. This means that A plus B is equal to 1. So this is my first equation. Then I can choose to substitute something else in there. Now I see that if I substitute 1/3, it'll cancel with the 3, then I'll have 1 plus 1. Same thing here, 1 plus 1. And then it'll reduce the 9 and the 6 over there. So substituting 1/3 might make my calculations easier. You can substitute 1 if you like. It doesn't actually matter. But try and make your calculations as simple as possible. So x is equal to 1/3. Okay, then when x is equal to 1/3, I will have A 3 times 1/3 plus 1. This is being squared. And then B 3 times 1/3 plus 1. And then C is not multiplying by anything, it's just there. And this should all be equal to 9 times 1/3 squared plus 6 times 1/3 plus 2. Okay, so I will have this one here. I will have 1 plus 1 because 3 times 1/3 is 1. Then 1 plus 1 is 2. 2 squared is 4. So I have 4a. Then here a third times 3 is 1. So I have 1 plus 1, which is 2. So I have 2b. C, we said must just remain there because it does, x has no effect on C. And then on the right hand side, that one you do on your calculator. 9 times a third squared, this is just 1. And then 6 times a third is 2. So I have 1 plus 2 plus 2. Okay, and this is equal to 5. Okay, so you can just check on your calculator that it is correct. Then remember that C is equal to 1. We got it over here. Then you substitute. So you have 4a plus 2b plus 1. This is equal to 5. This means 4a plus 2b is equal to 4. Then you can divide by 2 throughout. So you have 2a plus b, and this is equal to 2. So this is your second equation. So the first one was a plus b is equal to 1, and now I have 2a plus b is equal to 1. So I'll solve these simultaneously. So I have a plus b is equal to 1, and then I have 2a plus b is equal to 2. So we can use elimination. The coefficients of b are the same. So I will have to subtract. Then here I have minus a is equal to minus 1. This means that a is equal to 1. And then if I were to multiply out or even just substitute, I will get b is equal to 0. You can work it out. Get b is equal to 0. So I have the value of a over here. Then when I substitute it in this equation, I get b is equal to 0. So now I know what my coefficients a, b, and c are. Then I can rewrite it decomposed. So the decomposition this will just be a. Let me just write it. I have a over 3x plus 1. Then I had b over 3x plus 1 squared. And then I had c over 3x plus 1 cubed. So remember, this is 0, a I got 1, and c I got 1. So my final answer is just 1 over 3x plus 1 plus 1 over 3x plus 1 to the power of 3. So when you have a long term, or your exponent over here was a big number, you might see that some terms in the middle will disappear, like the one that we did over here. So that's how to do it if you have a linear term that is repeated. So even if it's repeated 5 times, write it those 5 times. And if it's repeated, if you have more than one that is repeated, let's say for example I give you this, so you can try this one later. Let's say I have x over x minus 1 squared and x plus 1 squared. Here I have 2 repeated terms. I must still do it in the same way. So I have a over x minus 1 plus b over x minus 1 squared plus c over x plus 1 plus d over x plus 1 squared, like that. That is how I must do it. And then you know how to solve for a and b. So it seems like it will be a long procedure. So even if I change this to 3, then I must see that x plus 1 squared, x plus 1 cubed. So later you can try this one and see what you get. Okay, then the next one we look at, let's try and squeeze this in for today's class, is when you have irreducible quadratic factors. So this irreducible quadratic factors. Okay, so with irreducible quadratic factors, that means you have a factor in the denominator, let's say for example x plus 1. Now x plus 1, you cannot factorize it any further. Now, yeah, you cannot factorize it any further and then write it in terms of its linear factors. So what you do is you will still work in pretty much the same way, except that your numerator in this case is a linear term. So here, when our denominators were linear terms or linear factors, my numerators were constants. They didn't have x. Now, when I have a quadratic factor in the denominator, my numerator must be linear. So it's 1 less than the degree of the denominator. Okay, so let's look at an example. The idea is basically the same. So when we have repeated, we must also do the building up to repeated. If none of them is repeated, then we just proceed in the normal way. Okay, so let's say I have 2x squared plus x plus 1 over x squared plus 1. Okay, now this one I have to decompose it. Now the denominator is factorized as far as possible. You cannot factorize it anymore. And this one over here, this is a linear factor. We know how to work with that one. And this one is irreducible quadratic. Okay, so when I write my AB, I do this, I will have A over X, and then I have BX plus C over x squared plus 1. So my numerator over here must be linear because what I have in the denominator is quadratic. Then I continue in the way that I always do. I have A times x squared plus 1. So I'm looking at my numerator. And then B times x, it's bx plus c times x. Okay, that's what I will have in the numerator, and this is equal to the numerator of the original question, which is 2x squared plus x plus 1. Then I try the substitution thing that I've been doing. So we can say let x equal to 0. Okay, so I see that when x is equal to 0, the term with b will disappear because it's multiplying by 0 over there. Then on the right hand side, this will be 0, that will be 0, I'll be left with 1. So I have a 0 squared is just 0 plus 1, and on the right hand side I have 0 plus 1, this is just equal to 1. So then I have a is equal to 1. So that is my first solution. Then going back again to my numerator, there's nothing I can substitute over here to get rid of the a, because x squared is positive for whatever term you substitute. So there's no way it can cancel with this minus 1 to give me 0. So what I do is I make another substitution. You can choose x is equal to 1, x is equal to minus 1. It is really up to you. It doesn't matter. But always try and pick a value that makes your calculations easy. So I will choose x is equal to minus 1. That's what I chose. So let x equal to minus 1. Okay, you can pick 1. That's also fine. You'll see that in the end our answers are the same. So let me just use 1. Okay, when x is equal to 1, so I have a and then I have 1 plus 1. Okay, so I'm just substituting because it's x squared, which is 1 squared, it's 1, and then b times 1 plus c. This is multiplying by 1, that's my left hand side, and then this should be equal to 2 times 1 squared, which is just 2, and then plus 1 plus 1 over there. So I'm just substituting x is equal to 1 on the left hand side as well as on the right hand side. Then what I have is 2a plus b plus c. This is equal to 4. Okay, but I already know the value of a. I already got it. It's over here. So I can also substitute a in there. So I will have b plus c. This is equal to 2. Okay, so what I have done is substitute the value of a, which is equal to 1, and then I take it to the other side, and that's why I have b plus c is equal to 2. Then now I will also substitute x is equal to minus 1, because this is one equation. This is one equation and I have two variables, so I need another equation like I did in the previous question. So when x is equal to minus 1, and where am I? I'm here. I'm going to substitute. Here I will just have 1 plus 1, so it's 2a. Then I have minus b plus c times minus 1, and then here I'll have positive 1 times 2, and then here I have minus 1. So you just do the substitution the way we always do. And then, so I substitute a is 1, then I have minus 1 squared plus 1 plus minus b, it's b times minus 1, which is minus b plus c, and then I multiply this by the x, which is minus 1. And on the right hand side I have 2 times minus 1 squared plus minus 1 plus 1. So this one over here, I said I'm already substituting a, so I want to do as many steps as possible in one. Then when I simplify, here I have minus 1 squared plus 1, that is 2, and then I have b minus c, because I will multiply this, becomes positive, and then that one is negative. And then on the right hand side I have 2 minus 1 plus 1, this is just equal to 2. Okay, and this leaves me with b minus c is equal to 0. So again, I have two simultaneous equations. I need to solve them. So I'm going to do it over here. I'll solve by elimination. So I have b plus c is equal to 2. Then b minus c is equal to 0. The coefficients of b and c are all equal, so I can start by subtracting. B minus b is 0, c minus negative c, this is just 2c, and this is 2, and this means that c is equal to 1. So that's my first solution. And then when I substitute it back in there, if I know that c is equal to 1, it obviously means that b is equal to 1 as well. So I'll just show, still using elimination. This is equal to 0, so this time I add. So I have 2b is equal to 2. This means that b is equal to 1. So I have all my values of a and b, then I write the decomposition. So the decomposition, we said I have, this is how it looked like. It was a over x plus bx plus c over x squared plus 1. Then I'm just going to substitute the values of a, b, and c. So a is 1, we said, b is 1, c is also equal to 1. So when I write this nicely, I have 1 over x plus bx plus, why am I doing that? Okay, b is 1, so it's just 1, and then plus 1 over x squared plus 1. And when the coefficient of x is 1, I don't even need to write it. So this is what my final answer will be. Okay, so that one is not too difficult. I want us to do just one more. Let's see if I have x to the power of 3 plus 6x squared plus x over x squared plus 1 x squared minus 1. Okay, so here I have one quadratic which is irreducible, and then the other one I can factorize it. So I should factorize this. So make sure your denominator is factorized as far as possible. So when I factorize this, I have x cubed plus 6x squared plus x. And then in my denominator, the first one I cannot factorize it, so it must remain as it is. And the second one is a difference of squares. Okay, so it's factorized like that. Then for the linear factors, I will put them over a. So I have a over x minus 1, and then b over x plus 1. So it doesn't matter whether you say a over x plus 1 or b over x minus 1. As long as when you come back and make the substitution for a, it is over the right denominator, then it doesn't matter where you put it. And then here I have cx plus d over x squared plus 1. So in the same way, I could have made this ax plus b, and then this one is c, and then that one is d. So it doesn't matter as long as in my final substitution, I put them back over the right denominator. Okay, then I multiply as usual and look at my numerators. So the first one, a, it's a, this multiplies by x plus 1, and then x squared plus 1, and then b will multiply with x minus 1, and then x squared plus 1, and then cx plus d will multiply with x minus 1, x plus 1, and this should be equal to what I have on the right hand side, which is x cubed plus 6x plus x. Okay, then I do the usual thing. Can I get rid of some of the a, b, c, and d? This, let me just write this nicely. Okay, that is a c. Okay, so I see that if I let x equal to minus 1, this term over here with a will disappear, and this term here with c and d will disappear. Then I can solve for b. Okay, so the x plus 1 term will disappear. Then what I have is, if x is equal to minus 1, then I will have b minus 1, and then I have minus 1 squared, which is just 1 plus 1, and then on the right hand side I will have minus 1 cubed, which is just minus 1, 6 times minus 1, which is minus 6, and then plus minus 1, which is just minus 1. Then on the left hand side I have negative 1 minus 1, it's negative 2, 1 plus 1 is 2, 2 times negative 2 is negative 4, so I have negative 4b. And then on the right hand side I have negative 8. This means that b is equal to 2. So that's my first solution. Then I go back and I see that if I substitute x is equal to 1, the term with b will disappear, and the term with c and d will also disappear, and then I will be free to solve for a. So I do that. I let x equal to 1. Okay, now if x is equal to 1, when I substitute, I will have a times 1 let's see. Okay, we see we're substituting 1, so I have 1 plus 1, that should be a 2. Yeah, it should be a 2. So I have 1 plus 1, and then x squared plus 1, that's 1 squared plus 1, that is also 1 plus 1. And then on the right hand side, 1 cubed is just 1, plus 6 times 1, this is just 6, and then plus x, which is just plus 1. So when I multiply this one out, 1 plus 1 is 2 times 1 plus 1, I get 4. So I have 4a. This is equal to 8, and this means that a is equal to 2. So now I have my values of a and b. Then to solve for c and d, I just make another substitution. I say let x equal to 0. Okay, the reason is there's no number I can substitute to get rid of the b, the a and the b, and just leave this one, because if I get rid of the a by substituting minus 1, the c and d term is gone. If I try and get rid of the b term by substituting positive 1, the c and d term is also gone. So I just pick any number that will make my calculations very easy to do, and that is 0. So I will have a 1 plus b, I have minus 1 and 1 plus d minus 1, 1, and this is equal to 0, because all the terms on the right are multiplying by x, and x is 0, and you see that c is gone because c was multiplying by x, which is 0, so you're only left with d to solve. Okay, so I have a minus b minus d, so it's minus d because of this minus 1. This is equal to 0. But then we know what a and b are. We solved those ones. A we said is 2. It's over there. A is 2 and b is 1. So let me just substitute. So we said a is 2 and b is also 2. So I have 2 minus d is equal to 0. This just means that d is equal to 0. Okay, then I come back and solve for C. So to solve for C, I just pick a number to substitute. So I will say let x equal to 2 because I'm squaring x somewhere and cubing it. I don't want to pick a very big number and end up with very big terms. So when x is equal to 2, I have a 2 plus 2 plus 1 because it's a times x plus 1, and then 2 squared plus 1, and then b is multiplying by x minus 1, so that is 2 minus 1, and then also x squared plus 1, so it's 2 squared plus 1, and then I will have c times 2, so it's 2c. So here I'm not going to write the d because I just don't want to write too many things, and also I know that d is equal to 0, so I'm not going to include that one. And then just to save space also. Okay, and then I have x minus 1, so this is 2 minus 1, and then 2 plus 1. That is my left hand side. But remember also that a is, what is a? A is 2, and b is also equal to 2. Okay, so you'll substitute that also in your calculations as well. All right, then the right hand side, if I substitute 2, I will have 2 squared, 2 cubed plus 6 times 2 plus 2. Okay, so when we multiply out, let's see, the first bracket, I have 2 plus 1, that's 3. 2 squared plus 1, that's 5. 5 times 3 is 18. 5 times 3 is 15. So I have 15 times a, but a is 2. So I have 15 times 2, which is 30. So I have 30. Then over here, I have 2 minus 1, which is 1. 2 squared plus 1, this is 5. So it's 5 times 1 times 2. There I get 10. So this is plus 10. And then over here, this is 2 minus 1, that's 1. This is 3, so it's 1 times 3 is just 3. And then times this 2, I get 6. So plus 6c. And then on the right hand side, I have 8 plus 12 is 20 plus 2, I get 22. Okay, so we make 6c the subject. So I have 22 minus 30 minus 10, you get minus 18. And then c is just equal to minus 3. Get minus 3. Okay, so check my calculations if I've done this correctly. And then after you have those values, what you can do is you substitute them back. Let me just see if I've done this correctly. It's 30, 22. Okay, looks fine. Then you can just rewrite them in the form of A, B, and C. C. Okay, so we had A, what is that? A, write it here. So we have A over x minus 1 plus B over over x plus 1, then cx plus d over x squared plus 1. Okay, then you substitute your values. We said a with a we said is 2. Let me just write that. So we said that a is 2, b was also 2, c we said is minus 3, and then d we said is 0. So we just rewrite it nicely. This is 2 over x minus 1 plus 2 over x plus 1, and then minus 3x over x squared plus 1. And then that is your final answer. Okay, so the last part of the chapter, I think those questions, figure them out because they're not too difficult. That is when you must use division. So your denominator will have a degree that is less than the numerator. So first you use long division, and then you can use this method that we have done so far. Okay, do we have any questions? Are you fine? Okay, if there are no questions, then Monday is a public holiday. The test should be on Tuesday. I think he said either Tuesday or Wednesday, so just prepare for a test on Tuesday. Yeah.